Students, next question. Use division algorithm to show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5, where q is any positive or any integer. Right? Let a be a any positive integer. What is that? Let a be is any positive integer and b, given b is equal to 6. By definition, of division algorithm, we have a is equal to bq plus r, comma 0 is less than or equal to r less than b. Now substitute b value in that equation. So what it becomes? A is equal to 6q plus r, comma 0 is less than or equal to r less than 6. So 0, it is nothing but 0 less than or equal to r less than 6. It means that r is equal to, we have remainder r is equal to, the values are 0, 1, 2, 3, 4, 5. So these are the values. Okay. If we substitute r is equal to 0, so our equation becomes a is equal to 6q plus 0, that is a is equal to 6q. So a is equal to 2 into 3q. So can we write like this? A is equal to 2 into 3q, and we, so it is divisible by 2. If it is divisible by 2, then it is nothing but it is even number. Okay. Next, if r is equal to 0, now substitute r is equal to 1. So what it becomes? A is equal to 6q plus 1. So which is not, here we cannot take 2 common, therefore it is not divisible by, so I'll write in the short, not divisible by 2. So if it is not divisible by 2, then that is nothing but odd integer. Okay. In the same way, if r is equal to 2, so a is equal to 6q plus 2. So a is equal to 2 common 3q plus 1, which is divisible by, 2. So if it is divisible by 2, then it is even. Next, if r is equal to 3, then what it becomes? Equation becomes 6q plus 3. Here we cannot take 2 as common, therefore it is not divisible by 2. If it is not divisible by 2, then it is of the form odd form. Next, if r is equal to 4, then a is equal to 6q plus 4. Yes, we can take 2 common here. 2 3s are plus 2 2s are. So which is divisible by, 2. So if it is divisible by 2, what I said, it is even. Next, the last one, that is r is equal to 5. A is equal to 6q plus 5, which is not divisible by 2. Therefore, it is odd. Now observe it. What is our question? What we have to show that? We have to show that any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. So observe here, if r is equal to 1, a is equal to 6q plus 1, it is of the odd form. Next, a is equal to 6q plus 3 is also odd form. Next, a is equal to 6q plus 5 is also odd form. Therefore, we have to write any positive odd integer is of the form 6q plus 1 or 6q plus 3 or 6q plus 5. So this is the proof. Right, next question. Use division algorithm to show that square of any positive integer is of the form 3p or 3p plus 1. 3p or 3p plus 1. Okay. So, proof. Let us prove. Let a be any positive integer. And what is b value? 3. B is equal to 3. By division algorithm, by definition of division algorithm, what is our equation? A is equal to BQ plus R, comma 0 less than or less than B. So A is equal to, what is B value? Just substitute here, 3Q plus R, comma 0 less than or equal to R less than 3. So remainder is 0, 1, 2. So if R is equal to 0, then equation becomes A is equal to 3Q plus 0, that is A is equal to 3Q. So what we have to prove? We have to prove that square of any positive integer. So we have to square on both sides. Squaring on both sides. What happens if we square on both sides? That is a square is equal to 3q whole square. So a square is equal to 3 square is 9 and q square. Okay. Let us take, or can we write like this? 3 into 3q square. So let 3q square I consider that as p. So what our equation becomes? A square is equal to 3p. Right? In the same way, next one, if r is equal to 1, our equation becomes a is equal to b 3q plus 1. Squaring on both sides, that is a square is equal to 3q plus 1 whole square. A square is equal to, that is, what is a plus b whole square? A square plus b square plus 2ab. That is the formula. A plus b whole square formula. So a square is equal to 3 square is 9q square plus 1 plus 2 3 is 6q. So a square is equal to 9q square plus 6q plus 1. So here we can consider 3 as common. 3q square plus 2. Okay, take 3 common. A square is equal to 3 into 3q square plus 2q plus 1. 3 into 3q square plus 2q plus 1. Since let us consider that 3q square plus 2q is nothing but some p. So what happens? A square is equal to 3p plus 1. Right? In the same way, if r is equal to 2, substitute r is equal to 2 in the equation, then equation becomes a is equal to 3q plus 2. Now squaring on both sides, what happens? A square is equal to 3q plus 2 whole square. So a square is equal to a plus b whole square expanded, 3q whole square plus 2 square plus 2ab. That is a square is equal to 9q square plus 4 plus 2 3 is 6, 6 2 is 12q. So a square is equal to 9q square plus 12q plus 4. A square is equal to 9q square plus 12q plus 3 plus 1, right? 4 as 3 plus 1. Can we write like that? Yes, we can write. Now among this, you take 3 common, 9q, sorry, 3 3 is a 9q square plus 3 4 is a 12q plus 1 plus 1. Now this total you have to consider as p. So what it becomes? A square is equal to 3p plus 1. Since you have to mention here 3q square plus 4q plus 1 is nothing but p. So that is the proof. So square of any positive integer is of the form 3p or 3p plus 1. So observe once, square of a square is equal to 3p. Next, a square is equal to 3p plus 1. And here also a square is equal to 3p plus 1. Therefore, square of any positive integer is of the form 3p or 3p plus 1. This is the proof. Next question. Use division algorithm to show that cube of any positive integer is of the form 9m, 9m plus 1 or 9m plus 8. So let us consider, let a be any positive integer. What is b value? If we consider b is equal to 9, so our answer become very lengthy. So what we have to write here is 3. Why I written here 3? Because 3 is the factor of 9. Yes, we can take 3 is the factor of 9. Instead of 9, so I taken here 3. Okay. Therefore, by definition of division algorithm, what is the equation? A is equal to b cube plus r, 0 comma 0 less than or equal to r less than b. Now substitute b value. What is the b value? 3. A is equal to 3 cube plus r, comma 0 less than or equal to r less than b is 3. So what are the values of r? Reminder, that is 0, 1 and 2. Right. So if I substitute r is equal to 0, then equation becomes a is equal to 3q plus 0. That is a is equal to 3q. Right? Now we have to show that the positive cube of any positive integer. No, let us cube it. Let us cube on both sides. Cube on both sides. So what it becomes? A cube is equal to 3q whole cube. So a cube is equal to 3 cube is 27 and this is q cube, right? So a cube is equal to, take 9 common, or can we write like this, 9 3s are 27 q cube. So since we consider 3 cube as some m, okay, according to this we have to take 9m is there, no? So let us consider that as m. So it becomes a cube is equal to 9m, right? In the same way, if r is equal to 1, if r is equal to 1, then our equation becomes a is equal to 3q plus 1, cubing on both sides. What it becomes? A cube is equal to, what is the formula? Before writing this one, we have to know the formula. I write the formula. What is a plus b whole cube? A plus b whole cube formula is a cube plus b cube plus 3a square b plus 3ab square. That is the formula. So we have to cube on both sides. Then, so a cube is equal to 3q whole cube plus 1 cube plus 3a square. A square is 3q whole square into 1 plus 3 into 3q into 1 square. So according to that formula, we expanded that one. Then a cube is equal to, it is 27 q cube plus 1 plus 3 into 9q square plus 3 3s are 9 q. So a cube is equal to 327 q cube plus 3 nines are 27 q square plus 9q. You write this plus 1 here. So a cube is equal to, among this we can take 9 common. So 9 table, 3 q cube plus 3 q square plus 1 q plus 1. Now consider this total as m. So a cube is equal to 9m plus 1. So we have to mention here, what is that? 3q cube plus 3q square plus q is nothing but that is equal to m. So that is the a cube is equal to 9m plus 1. Next, if r is equal to 2, so the equation becomes a is equal to 3 cube plus 2. Now cubing on both sides, that is a cube is equal to, right, according to that formula, what is that? A cube 3 cube whole cube plus 2 cube plus 3a square. It is 3q square into b plus 3ab square. AB square. That is 1 square. So a cube is equal to, it is 27q cube plus 8 plus 3 into 9q square plus 3 3s are 9q. Therefore a cube is equal to 27q cube plus 3 9s are 27q square plus 9 cube plus 8. So among this we can take 9 common. So it becomes 3q cube plus 3q square plus q plus 8. So consider this total as m. A cube is equal to 9m plus 8. So we have to mention here, what is that? 3q cube plus 3q square plus q is nothing but m. Now observe it. Cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8. So here a cube is equal to 9m. Next, here also a cube is equal to 9m plus 1, and lastly a cube is equal to 9m plus 8. Therefore we have to write cube of any positive integer is of the form 9m or 9m plus 1 or 9m plus 8. Next question, show that one and only one out of n comma n plus 2 or n plus 4 is divisible by 3 where n is any positive integer. Okay, as usual, like previous answers. So let us prove this one. Proof. Let, here we have to consider not a, but he mentioned here n. Let n be any positive integer. Any positive integer. And what is b value? B is equal to 3. So b value is given, which is divisible by 3. So b value is 3. So by definition of division algorithm, division algorithm, we have equation a is equal to bq plus r comma 0 less than r, 0 less than or equal to r less than b. Now so a is equal to bq plus r, but what is a here? According to our consideration, a is nothing but n. N is equal to b. What is the b value? It is b value is 3 3q plus r. So 0 less than r equal to r less than 3. B is 3. So then r is equal to 0 1 2. So if r is equal to 0, then equation becomes n is equal to 3q plus 0, that is n is equal to 3q. Okay, so here n is divided by 3. So 3 divides n. Next, n is equal to 3q. So out of 3, we have to prove that at least 1 must be divisible by 3, no? So here n is divisible by 2, divisible by 3. Next, now we have to check whether n plus 2 is divisible by 3 or not, and n plus 4 divisible by 3 or not. Let us check. N is equal to 3q. This is the equation. Now what we have to do is, we have to add 2 both sides. So what it becomes? N plus 2 is equal to 3q plus 2. So since add 2 both sides. Okay, now we are adding. Is it divisible by 3? There is no possibility. Therefore, we can say that n plus 2 is not divisible by 3. In the same way, now we have to check one more, that is n plus 4. So what is our equation? N is equal to 3q. Now this time we are going to add 4 both sides. What it becomes? N plus 4 is equal to 3q plus 4. Add 4 both sides. Okay. So if we add, is it divisible by 3? N plus 4 is not divisible by 3. Not divisible by 3. Therefore, only 1 is divisible by 3. What is that? N. N is divisible by 3 and n plus 2 is not divisible by 3. Next, n plus 4 is not divisible by 3. Therefore, for condition r is equal to 1. Now we have to check for the condition. If r is equal to 1, then what is our equation? N is equal to 3q plus 1. Okay. Is it divisible? N is divisible by 3. Here, n is not divisible by 3. Next, n is equal to 3q plus 1. This is the equation. What we have to check, n plus 2 is divisible by 3 or not. So to check that one, we have to add 2 both sides. N plus 2 is equal to 3q plus 1 plus 2. Add 2 both sides. Okay, what it becomes? N plus 2 is equal to 3q. 1 plus 2, it is 3. Now here we can take 3 common. Then it becomes 3 into q plus 1. So can I write like this? N plus 2 by 3 is equal to q plus 1. Yes. N plus 2 is divisible by 3. Therefore, n plus 2 is divisible by 3. Okay. Let us check one more. That is n plus 4. Whether n plus 4 is divisible by 3 or not. So to check that one, first we have to write that equation. What is that equation? N is equal to 3q plus 1. Add 4 both sides. Then what it becomes? N plus 4 is equal to 3q plus 1 plus 4. N plus 4 is equal to 3q plus 5. So here we cannot take any common. Therefore, simply we can say that therefore n plus 4 is not divisible by 3. So for condition r is equal to, when r is equal to 1, n is not divisible by 3, n plus 2 is divisible by 3 and n plus 4 is not divisible by 3. In the same manner, now we have to check if r is equal to 2. Then what is the equation? N is equal to 3q plus 2. So is it divisible by 3? N is not divisible by 3. So what is the next condition? N plus 2. So let us write the first equation. N is equal to 3q plus 2. Add 2 both sides. What it becomes? N plus 2 is equal to 3q plus 2 plus 2. So n plus 2 is equal to 3q plus 4. We cannot take any common. Hence, we can say that n plus 2 is not divisible by 3. And the next condition, n plus 4. So first write the equation. N is equal to 3q plus 2. Add 4 both sides. So n plus 4 is equal to 3q plus 2 plus 4. So n plus 4 is equal to 3q plus 6. Yes, we can take common here. If 3 common. So what it becomes? 3 into q plus 2. 3 to the 6. So we can write this as n plus 4 by 3 is equal to q plus 2. Yes, 3 divides, or n plus 4 is divisible by 3. So this is the proof for fifth question. So one and only one out of n comma n plus 2 comma n plus 4 is divisible by 3. Therefore, you have to write here out of one and only one out of n comma n plus 2 comma n plus 4 is divisible by 3. That is the proof of for the question number 5. Next question, think and discuss. If R is equal to 0, then what is the relationship between A, B and Q in A is equal to BQ plus R? So what is our equation? Given equation. Given equation, that is A is equal to BQ plus R. In this equation, if R is equal to 0, what happens? Then A is equal to BQ plus 0. So it is nothing but A is equal to BQ. So we may write that as A by B is equal to Q. So what does it mean? So B divides A completely. B divides A completely. If B divides A completely, then we can say that B is the factor of A. So this is the relationship between A, B and Q. Okay. Okay, next to theorem 1.2, fundamental theorem of arithmetic. So what is the statement? Every composite number can be expressed as product of primes, and this factorization is unique apart from the order in which the prime factors occur. Okay. So what is the statement? Every composite number can be expressed as product of primes. Okay. Every composite number can be expressed as product of primes. Let us take one example. So 32 is a composite number. Okay. So this composite number we can write as 2 ones are. Let us take the prime factors. 2 ones are 2. So 1 remains. 1 2 it becomes 12. 2 6 are 12. Next 2 8s are 2 4s are 2 2s are 2 ones are. So approximately we can take, not approximately, therefore we can write 32 as 2 power. How many 2s are there? 1 2 3 4 5. 2 power 5. So let us take one more. 64. One more example. 2 3s are 2 2s are 2 ones are 2 6 are 12, 2 8s are 2 4s are 2 2s are. Again, we are getting the same values here. I mean, 2 power 1, 2, 3, 4, 5, 6. So, 2 power 6. So, these are the prime factors. Observe this. So, 64 is an composite number. Next, 2 power 6 are the prime numbers. Okay. So every composite number can be expressed as product of primes. Not only that one, take one more, that is 108. What it becomes? 108, 2 5s, 2 4s, 2 2s, 2 7s. Now 3 table 3 9s, 3 3s, next to 3 ones. So we can write 108, that is the composite number, as 2 power. How many 2s are there? 2 into 3 power 3. So these are the product of primes. Product of primes are nothing but a composite number, or composite number can be expressed as product of primes. So this, okay, next to do this question, express 2310 as a product of prime factors. Also see how your friends have factorized the number. Have they done it in the same way? Verify your final product with your friend's result. Try this for 3 or 4 more numbers. What do you conclude? So, he has given one number. What is that number? Given number 2310. Now, this 2310 we have to find the product of primes, that is 2 ones are 2, 2 ones are 2, 1 remains, 1 1 it becomes 11, 2 5s are 10, 1 remains, 1 0 10, 2 5s are 10. So the last digit is 5, then we have to go with number 5, 5 2s are 10, 1 remains, 5 3s are 15, 1, so 1 5 ones are 5. Next 3 table, 3 sevens are 21, here 2 remains, 2 1 it becomes 21, 3 sevens are 21. Now let us take the 7, number 7, 7 ones are 7, 7 ones are 7. Next 11, 11 ones are 11. So therefore, we get 2310. The number 2310 is equal to 2 into 5 into 3 into 7 into 11. So if you observe, all these are all are primes. Okay. So before that, we have studied the statement or arithmetic theorem. What is that arithmetic theorem? Or composite, every composite number is the product of primes. So this is the composite number and these are the prime numbers, right? So now what you have to do is you have to check the same result with your friends, whether what is that? Also see how your friends have factorized the number. Have they done it in the same way? Verify your final product with your friend's result. Try this for 3 or more. Take this type of numbers, 2, 3 or 4 more and try it. What is your conclusion? So what you have to write? My conclusion is every composite number is a product of primes. Product of primes and its factorization is unique. Its factorization is unique. So this is the conclusion we get. Okay. Okay. Next to do this question, find the HCF and LCM of the following given pairs of numbers by prime factorization method. Now we have to find HCF and LCM by using prime factorization method. Okay. The first question is 120 and 90. So let us write the factors of prime factors of 120. So 2 6 are 12 and 0 200. Next 2 3s are 6 zeros are. Next 2 1s are 2 1 remains 1 0 it becomes 10 2 5s are 10. Now we can take 3 table 3 1s are 3 sorry 3 5s are 15. Next 5 5 1s are 5. In the same manner find the factors of prime factors of 90. So 2 table 2 4s are 8 1 remains 1 0 it becomes 10 2 5s are 10. Next 3 table 3 1s are 3 3 5s are 15. Next 3 5s are 15. Next 5 1s are 5. Right here 120 prime factors are 2 power. How many 2's are here? 3. That is 2 cube into 3 into 5. Next 90. 90 prime factors are 2. How many 2's are here? Only 1 2 into how many 3's are here? 2 3's, that is 3 square into 5. Okay. Then what we have to find? We have to find HCF and LCM. So first of all, let us find LCM. So what is LCM? So here, how many numbers are here? 235, 235. You just write the 2 into 3 into 5. The numbers which we have in the both the numbers, you write it and compare the powers. So for finding LCM, we have to compare the powers. So here, the power of 2 is 3 and the power of in 90 the power of 2 is 1. So whose power is highest? So here the power of 2 is 3. 3 is the highest number, you write here 3. Next in 3 the highest power is 2 and in 5 there is no highest power, both are same. So just write power 1. Then LCM is equal to 2 cube is nothing but 8. 2 into 2 into 2. 2 2s are 4, 4 2s are 8 into 3 square. 3 into 3 it is 9 into 5. Now multiply individually 8 9s are 72 into 5. Next LCM is equal to 5 2s are 10, 5 7s are 35 plus 1 it is 36. So what is the LCM? LCM of 120 and 90 is 360. Next we have to find HCF. A quite opposite to LCM. So we have to check the common numbers. So the common numbers both in 120 and 90, common prime factors, that are 2, 2, 3, 3 and 5, 5. So you write 2 into 3 into 5. So in LCM we have consider, or we have taken the highest power, no? But here we have to take the least powers. 2 power 1, 3 power 1 and 5 power 1. So HCF is equal to 2 into 3, 6, 6 5 is 30. That is the HCF of 120 and 90. What is LCM? LCM is equal to 360 and HCF is equal to 30. In the same way, let us find next question 50, 60. Find the prime factors of 50. 2 2s are 4, 1 remains, 1 0, it becomes 10. 2 5s are 10. Next 5 5s are 10. 5 1s are 5. Next 60. 2 3s are 6. 0s are 2 1s are 2. 1 remains, 1 0, it becomes 10. 2 5s are 10. Next 3 5s are 15. 5 1s are 5. So right here 50 prime factors are 2 into 5 square and 60 prime factors are 2 square into 3 into 5. LCM. Let us find LCM. So what are the numbers? 2 5, 2 3 5. So the numbers are 2 3 5. Three numbers are there. What are they? 2 3 5. Now compare their powers. While comparing in LCM, we have to take the highest power. The highest power in 2 is 2 square. Next highest power in 3 is, there is only 1 3, you write as it is. And the highest power in 5 is 5 square. So LCM is equal to 4 into 3 into 25. So LCM is equal to 4 into 25, it is 100. 100 into 3, it is 300. So LCM is 300. Next HCF. What is HCF? So what are the common numbers? We have to take only common numbers. Here the common number is 2 in 50 and 60. The common number is 2 right here. Next common number is 5. You may get one doubt, sir. In 60 there is 3, but in 50 there is no 3. Therefore, don't write this 3. Just we have to take only the common numbers 2 and 5. Then compare their powers. We have to take the least powers. So what is the least power in 2? That is power 1. And the least power in 5, that is 1. So HCF is equal to 10. So LCM and HCF of 50 and 60 is 310. Next question, third question. Find LCM and HCF of 37 and 49 by prime factorization method. So 37 is equal to 37 only. Why? Because 37 is a prime number. There are no factors, only one factor, that is 1. Next 49, we write 49 as 7 sevens are 49 or 7 ones are 7. So we can write that as 7 square. Now what is the LCM? LCM is equal to 37 into 7 square, or that is 37 into 49. So what is the answer? 37 into 49, you multiply it. 9 sevens are 63, 6, 9 threes are 27 plus 6. 27 plus 6, how much? 33. Next, 4 sevens are 28, 2 carry. 4 threes are 12 plus 2, 14. So it is 3. 3 plus 8, it is 11. 3 plus 5, it is 8 plus 1. So what is the answer? 18, 13 is the LCM. Next, we have to find HCF. What is HCF? What I said, we have to take only the common numbers from both the numbers, or common primes from both the numbers. So in 37, 37 is there. In 49, 7 square is there. There is no common number. When there is no common number from the given, when there is no common prime from the given numbers, then its HCF is always 1. So what is the HCF? It is 1. Or when the two prime numbers are given, then its HCF is always 1. Okay. This is your answer.